Hello students, in the last lecture we studied 5-member heterocyclic compound as a pyrrole. Today we are going to start furan as a aromatic compound. It is a heterocyclic compound. See the structure of furan. Here unhybridized p orbital. Here sp2 hybridized orbital. Now see the properties of furan. Furan have 4 carbon and 1 oxygen. All are sp2 hybridized. sp2 hybridization is planar. It makes a planar furan ring structure. Each ring atom also contain unhybridized p orbital that is perpendicular to the plane of sigma bond. Here p orbital are parallel to each other, so overlapping between p orbital is possible. The total nucleophile of non-bonding electron are 6, 4 of 4 carbon, 2 from 1 oxygen. The resonance of 6 electron follows the Hockel rule, so the furan is aromatic. Now see the synthesis of furan. The first synthesis of furan is the Palnor synthesis of furan. The statement of Palnor synthesis is acid catalyzed cyclizing dehydration of 1,4-dicarbonyl compound. Here reactant is 1,4-dicarbonyl compound in presence of H plus to give furan as the product. Now see the mechanism of Palnor synthesis. Here 1,4-dicarbonyl compound in presence of H plus, lone pair of oxygen abstract H plus. Now in next step, lone pair of oxygen attack here and stabilize positive charge on oxygen, and 5-membered ring is formed. Now in next step, here H plus is present, minus H plus shift here, and then this lone pair attack here. Now in next step, H plus is present, this H plus lone pair of oxygen abstract this H plus ion, here H2O plus. Now in next step, H plus shift here and H2 is a good leaving group is leave. Now see the structure of furan. It is the final product. Now see the second synthesis of furan, Fist-Benary synthesis. Now see the statement of Fist-Benary synthesis. Reaction of alpha haloketones with beta ketoester in the presence of base, not ammonia, to give furan. The first reactant is the alpha haloketone. Second is the activated ketone in presence of NaOH to give substituted furan as the product. Now see the mechanism of Fist-Benary synthesis. Here one reactant is present in presence of minus OH, this H plus abstract here, and here minus negative charge is present. This negative charge attack this carbonyl atom and give this structure. Minus H plus here, O minus attack here, and chlorine is the leaving group. In next step, 5-membered ring formation, minus H2O is leaving group, and final product is formed. Now see the third synthesis of furan. The statement of from carbohydrate, step first is distillation of CH with sulfuric acid. Step second, catalytic decomposition of furfural in steam. Pentose in presence of H plus to give furfural. In presence of steam, calcium oxide to give furan as the product. Now see the reaction of furan. First is the electrophilic substitution reaction. It is same as pyrrole. Furan undergoes electrophilic substitution reaction at second position. Here furan is present, electrophile is present. Here second position reaction are present. Here 3 resonating structure. Here third position reaction, here two resonating structure are present. Reason C2 attacks gives more resonance contribution structure than C3. Extra stable contributing structure generates upon C2 attacks. Now see the reaction of furan. Electrophilic substitution reaction of furan is same as the pyrrole. Furan in presence of H plus, lone pair of oxygen shift here, this bond shift here, and this bond attack on H plus to give this structure. Now in second structure, lone pair of oxygen attack here, this bond attack on H plus and form this structure. Leave in presence of H2O to give succinaldehyde as the product. Now see the nitration reaction, sulfonation reaction, chlorination reaction and acetic anhydride reaction. Now see the first nitration reaction. In furan nitration reaction, product is the nitro group attached to the second position plus here second position, also here is also second position. Counting here 1, 2, 3, 4, 5. 1, 2, 3, 4 and 5. Here 1, 2, 3, 4 and 5. Now see the sulfonation reaction. SO3H group attached second position. Now see the chlorination reaction, chlorine group attached to the second position. Now see the acetic anhydride reaction is group attached to the second position. Now see the reduction reaction. Furan in presence of H2 nickel to give tetrahydrofuran as the product. Now see the Diels-Alder reaction of furan. Oxygen atom is highly electronegative, so the delocalization of lone pair of electron is not overly effective. Thus, furan can behave as a dienophile and gives 4+2 cycloaddition reaction. Here, two reactants are given. One is diene and another one is dienophile. Here, this bond attack here, this bond shift here, and this bond attack here. Now see the product. Here Diels-Alder reaction mechanism here. Here give the exo product and endo product. Now see the pyrrole synthesis from furan. It is the industrial process. This reaction see in pyrrole synthesis. It is industrial process passing furan over ammonia in presence of aluminum as a catalyst at high temperature. This reaction furan in presence of ammonia to give this structure, furan in presence of primary amine to give this structure. Now see the medicinal uses of furan. The first medicinal use is the nitrofurans, nitrofurazone, furazolidone, nitrofuratum, anti-ineffective agent used as an antiprotozoal agent to treat tryptanoosmosis and leishmaniasis. Now see the structure here. Second medicinal use is the ranitidine, antihistamine agent used as a peptide ulcer. Thank you.